for it. So yeah, we had a really good discussion. Sort of to kick it off, Manuel had a really good summary of sort of the three areas that he saw machine learning being able to contribute to hybrid simulation, and those were simulating nonlinear responses, simulating complicated subsystems, and parameter ID. Mahindra raised a really good question, challenging question that nobody quite was ready to take on, but talking about extreme environments. So his examples were moons, Mars, international space stations, where you don't necessarily know the inputs to your model and how extreme they may be, and how potentially machine learning could be used for that. And again, that was a question he posed, and nobody quite was ready to answer. So maybe that's an open question. In terms of accelerating the work that we do, we talked about you could sort of accelerate the hybrid test itself. So being able to, for example, run larger models in real time, but also accelerating on the front end, actually getting to the stage where you're able to test in terms of building your setup. So potentially some simplifications there, as well as accelerating the modeling side to get to that numerical model for the hybrid tests. One thing, I'm going to jump down a little bit in terms of what we need as a community to build our capacity. Something that was raised there is having an open community where codes and whatnot are shared amongst individuals. And so, for example, like posting that to GitHub or something like that, where others could take it and run with it. Also, we talked about how workshops like this are really important in terms of bringing together the community that's working on these problems, sharing ideas. And so again, this is the whole idea of sort of open knowledge, open discussion, and being a community that sort of supports each other so we can all grow better. Nick Warsheim, he gave an idea, and we don't know if it's necessarily related to machine learning, but he actually brought up your university consortium on shake tables and whether or not to sort of try to lower the bar for entry into hybrid testing, whether there could be a program like this. And this came up in the testbed section a little bit, but also sort of building that capacity, right? So thinking about training, potentially even at the undergraduate level, to get students thinking about this stuff, so that maybe they want to go and pursue a PhD in the future. So we didn't really have ideas what that would look like, but it was a good idea, I thought. And I'll stop there just so other groups can probably say more.
Sounds great. Thank you. Thank you very much. Is there a second volunteer from a different group?
I think Gastón is volunteer himself first.
Great. Thank you, Gastón.
Thank you, Professor. Can you hear me?
Yes, we can.
Okay, perfect. I had a problem with my earphone. So, okay. In our group, we talked mainly about two questions posed to us. The first one was related to how could we use machine learning to extract more information, and the second was related to how to build capacity in ML in this community. The main outcome from this discussion is that, first of all, machine is a very useful tool. In conjunction with a hybrid simulation, we can basically conduct experimental tests of complete system instead of running tests only on one component, and that will give us more realistic results compared to other kinds of experimental techniques like pseudodynamic testing or shake table. So expand the boundaries of hybrid simulation, adding these kind of techniques. the issue is that this could pose a danger and challenges that we need to be aware before even thinking about including machine learning in the first place. We discussed about the importance of data, not only that data should be of good quality for running training and validation of our machine learning models, but also to be very aware that these kind of models maybe are not very good suited to extrapolate results. One thing that we discuss in this group is that machine learning maybe it's very good to predict results in the boundary of the data that was used for training and validation, but maybe not good enough for other kind of purposes. So we need to be very cautious of how we include machine learning in this scheme, in hybrid simulation scheme. So in order to bridge that gap, we need expertise. And that connects to the second question about building capacity in machine learning. We agree with the first group. We need benchmark data to try to train new generations of researchers and engineers in hybrid simulation to try to be more confident how to use these tools. Maybe we're not going to develop new methods in machine learning. Maybe using current tools is good enough, but we need to be aware that these tools have limitations, and we need to include that information whenever we have to make decisions on how to include these new techniques in hybrid simulation and real-time hybrid simulation. The other issue that we identify is we not only need good data or high quality data to train our models, we also need large data sets to train these models. So that could be very easy if we are training machine learning models from data that was simulated, for instance, from a finite element model. We basically are doing a reduced order modeling through machine learning, and that could enhance the accuracy, and we can get more realistic responses in cases where we include that in hybrid simulation tests or real-time hybrid simulation tests, especially in real-time hybrid simulation tests where we have real-time constraints and we don't have enough time to make these computational calculations in very small time steps. But the problem is, what happens if we want to do model updating, for instance, where the data is collected from the test itself? We also need large data sets, and that could pose a problem if we want to get information from machine learning from very small data sets. That is something that we also identified as a challenge, and we need to take a closer look on that in the future. There were other recommendations from the group. One recommendation, maybe we could include machine learning for feedback control, maybe create control schemes using machine learning. That could be an interesting way of using this technique in the future. And I think, and the other that was suggested in the group, there are conventional machine learning tools like the conventional neural network, which is basically a black box model, which doesn't have any information on the physics of the problem whatsoever. And there's a new trend of neural networks, which are physics-informed neural network that will try to capture and represent the physics, and maybe will have better capabilities for extrapolating the data that was used for training and validation. that could be something worthwhile trying to explore in the future and could be very suitable for this community. I think that's my summary.
Gabby,
Yes.
you're the third group. Thank you.
Yes. I was trying to wait whether I should jump ahead or wait for you to like leave the ball to me. So first off, I would like to thank everyone participating in the discussion, as well as our great scribe. They said Janet, I didn't get a chance to introduce her in that small group, so I want to mention her. So I just want to summarize what we did in our group. So we talked a lot, as everyone else, about the data side, as well as where the data coming from and what type of a problem definition that we're looking at for machine learning. And then we can look at the component level of machine learning or the entire structural level. I think from the cohort of our discussion, then we found actually we are at the stage that's moving from the component level to the system level. And then the data that's available is one key question that's coming from the discussion group. So there is the resource of NERI, and then there are in our team, Tracy Becker is using this intensive data from NERI to train her machine learning model to sample, to create the initial hybrid simulation numerical substructure. But the problem is that the non-unified data that we see from the NERI design safe is still not satisfying the quality of the machine learning training data set. So this is something that we discussed, and as well as how is this the different pieces of a component actually putting up together to help us understand the structural level performance is something that we discussed, and as well as about the sampling part of machine learning. So we need, again, as everybody discussed in other groups, we need not only the large data set, but also we need the data set that occur at the extreme cases, which is the corner cases. Dr. Eric Johnson popped up with that question, where do we obtain these extreme data, and then how we trust this machine learning, whether it's in the extrapolation instead of interpretation. So I think that is another angle to look at the application or the improvement that we can provide to the group as some additional tools. Let me see what else we have discussed. We also discussed about the test bed that we can use for machine learning or hybrid simulation within machine learning. So the hybrid simulation, the role that in the group that discussed in machine learning is, again, the selection of the numerical substructure or the numerical model, and without having any bias in the modeling. We shouldn't assume that even the design of the experimental substructure as well as numerical substructure, basically the setup itself can be something that we can learn from machine learning, and that will benefit the outcome the most. So we assume an unbiased selection. And then another part is where we see that the large data set can be coming from is this uncertainty type of uncertainty propagation type of a problem. And that is where that most of the intensive data that are coming from our perspective. And one particular resource that we pointed out is the SimCenter toolchain. And personally, I also benefited from that tool set. So there is a lot of capacity to be added, including uncertainties in your and also surrogate models in your simulation, and also how to benefit the deterministic real-time or hybrid simulation by among this uncertainty propagation. I think Dr. Ali M4, he actually used he tackled a lot on the uncertainty side, and he mentioned that uncertainty actually is everywhere, that in your simulation, and then using actually the hybrid simulation with updating at least can reduce the uncertainty from the model selection side. So that is one angle that we are looking at from as a group from the machine learning hybrid simulation in machine learning or the machine learning application in hybrid simulation. So I think, and also on the test bed side, what I'm also doing right now, as also summary from that discussion, is the regional simulation. So on the opposite, not on the opposite, but parallel with uncertainty propagation is if we are looking at the expanded region, and then that naturally provide us the various of data from building information, various data from ground motion, where that's what we're talking about, earthquake. And then on the wind side, that we have also different test beds. So I'm just trying to point, probably not try to point, but just summarize what we have discussed and provide this type of resource that I think the team is aware of. And I think that's probably all that we covered in our discussion. I don't know whether it fits into the linear question list, but I think thanks everyone that joined the discussion provided very fruitful comments on all different topics. That is my summary.
Sounds great. Thank you to the discussion leaders. Thank you to the students, Manuel, Edwin, Mahindra, and Lizette, who are helping as scribes for each of these. I'd like to see, we're actually on time, which is amazing. I'm gonna see if there's any comments where maybe something was left out or somebody had a new inspiration. But also, before I do that, let me just mention that what we will try to do is synthesize the various discussions and the recommendations made into a short report that we will post on the website. We'll send out an email about that. And we'll post these recordings sooner than that and let everyone know. If you are interested in having more workshops like this and maybe even having one in person, I did put the link to vote again. For NARI Researcher Summit sessions, you can vote for the MECHS session in particular and whatever else other ones you think are really good ideas. But let me before we close up the meeting, let me see, is there anyone who has a comment? Maybe we did not get to a topic that is also a good idea.
I guess surely this is Jim. One aspect is maybe on the computer horsepower for training all these networks. Going to require some resources. I guess there's an infrastructure maybe in place with the sim center and the cyber infrastructure, but being able to use high performance computing definitely is I think an attribute, right, in something like this, because then it takes less time to train something maybe to the level of accuracy you like to achieve.
True. I mean, I think the training may take quite a while, but the implementation of that network, once it's trained, is going to be fairly quick. I guess it depends on the network, of course, but there probably are some resources at DesignSafe that help with such training, and I would guess that those are available. I don't know the details. Maybe Gilberto, since I see him on, he may have some comments on that. Maybe not. Tracy, do you know? Is Tracy here? Okay. If we can find out any more information about that, we'll distribute it as well. Jim, that makes a good point. So
Thank you, sir.
Yeah. Again, I think that this was a lot of fun for a Friday afternoon. Hope you guys all enjoyed it and learned a lot, and we will continue this. So if you're interested, just keep your eyes out for further workshops. We generally have a couple a year, some in person, and look forward to your participation in the future. Thanks, everyone.